Circle is the topic for the day. To come with introduction, what is a circle? We have come across the word circle in many circumstances in real life. A circular wheel, which we talk about, a circular ring is what we have many instances where we have a circular shape. Now we all know that a circle is a round shaped figure. So this is how a circle looks. But how do we define mathematically a circle in a more mathematical sense? Now comes the question here that if I take this is circular, or this is a circle which I have drawn on the board. So what makes me call this as a circle, and why is it taken as a special case in its respective discussion, is the biggest question out here. Now circle has many properties which we come across, which we'll be studying in future, but now let's see what exactly is the mathematical definition of a circle. Now let's see the mathematical definition of a circle. Now imagine I have a circular wheel. Now this is a circular wheel. Now we know that this wheel has all its spokes which are equal in length. So if I take a bullock cart wheel, then in this case I clearly see that each of the sticks which are attached to the end points of the rim of the wheel are equal, that is, they are equidistant, which makes me understand that in order for a perfect circle to be formed, the distance from center to each of the edges of the circle must be same, which is a real life example of a bullock cart wheel which we have seen. So therefore this concept of a wheel having equal sticks from the center to the rim of the wheel is what defines the equation, or defines the circle in the mathematical sense. So the same bullock cart wheel which I take in the form of defining a circle, I say that the set of points in a plane which are equidistant from a fixed point. That is, if I take this as the fixed point, then each of the points on the rim are equidistant, as can be seen out here. Therefore, any point I take from the fixed point to this, to this, to this, or this are equidistant. Therefore, in the mathematical sense, I define a circle as the set of points in a plane which are equidistant from a fixed point, which is called the center of the circle. So defining is set of points equidistant from a fixed point is what I define a circle. So in mathematical sense, a circle is the set of points in a plane equidistant from a fixed point, as can be seen here with a more real life example of a bullock cart wheel. And the fixed point is called the center, and equidistant, the distance, is called the radius. The two important concepts of a circle are center and radius, which are defined from the mathematical definition of a circle. Now, therefore, for a circle with a fixed point which is equidistant to any of the rim or the circumference of circle, this fixed point is called center of circle, and the distance is called radius of circle, which comes out to be this. So the center is the fixed point here and the distance here is called radius of circle. Therefore, center and radius define a circle in the mathematical sense of understanding, as can be seen here. Now let's see how we can derive for equation of a circle. Now let's see the equation of a circle. Now that we have defined a circle in the mathematical sense, the next question which comes is, what will be the equation of a circle? As for example, if I take x-axis, y-axis and origin, I take a straight line, then I know that this straight line has the equation y equals mx plus c, is how we understand. Now similarly, when I take x, y and this, if I take a parabola, then I know that this has a parabolic equation y equal to x squared. So different shapes have different equations, like a straight line is given by this equation and a parabola is given by this equation. Now comes the biggest question: if I have a circle which is in the form of this, then what will be the equation of this circle is the biggest question out here. So we are going to discuss now on what would be the equation of circle in xy coordinate system in its different form. Now let's see the standard form of equation of circle. Initially, what is the standard form? If I take the circle with center as origin, then we call that as a circle in standard form. That is, if I have an xy coordinate system where the circle is exactly at the center of the origin, then in this case, if my radius is r, then in this case a circle with center as origin and radius as some r is given by the equation of circle is given by x squared plus y squared equals r squared. Is called standard form of equation of circle. So this called the standard form, where if I have a circle with center as origin and radius as r, then equation of circle is given by x squared plus y squared equal to r squared, the standard form of circle. Now let's see one of an example problem supporting the standard form of equation of circle. Say for example, I have a problem which says find the equation of circle whose center is origin and the radius is 3 units, is the question out here. So for the problem which says find the equation of circle whose center is origin and the radius is 3 units, then I clearly understand this problem related to the standard form, because standard form of circle has its center at origin and with radius r. Therefore, for the circle whose center is origin, that is 0, 0 in xy coordinate system, and radius which is 3 units, using these two, I have the equation of, I have the circle which is like this: x-axis, y-axis, and this with center origin and radius 3 units. Now let's find equation of this circle where the center is origin and the radius is 3 units. We know that equation of circle with center origin and radius r is given by x square plus y square equals r square. That implies my r, which is 3, gives me x square plus y square equals 3 square. That implies x square plus y square equal to 9 is the answer. Therefore, when I just substitute the radius in the standard equation x square plus y square equal to r square, then I get the equation of circle in standard form, and here being x square plus y square equals 9. So therefore, equation of circle whose center is origin and radius is 3 units is x square plus y square equal to 9, the standard form of the circle. Now let's see the equation of circle with center as hk, that is when the center is not origin. Therefore, for this circle with center as non-origin, let's see what would be the equation of that circle in the non-standard form. So for example, if I have x-axis, y-axis, origin, when I have a circle with center hk, so with center hk and radius r is given by the equation x minus h whole square plus y minus k whole square is equal to r square. So this is how we define the equation of a circle with center hk and of course radius r. X minus h whole square plus y minus k whole square equal to r square. Let's see an example problem to support equation of circle with center hk. So for example, I have a problem which says find the equation of circle with center 2, 3 and radius equals 5 units. So in this case, I clearly have the center which is non-origin, that is 2, 3, and my radius is 5 units. Therefore, when my center is 2, 3, that implies clearly my h is this and my k is this. So h is 2 and k is 3, the x coordinate being h and the y coordinate being k. H equals 2 and k equals 3, and my radius is 5 units. Implies r equal to 5. Therefore, for equation of circle where the center is 2, 3 and the radius is 5, I have the equation given by x minus h whole square plus y minus k whole square equals r square. And then using this, I have h, k and r, which I am going to substitute in the equation. That implies my h is 2, therefore this is x minus 2 whole square, and my k is equal to 3, therefore it is y minus 3 whole square, that is equal to 5 square, which is the radius. Now this gives me x minus 2 whole square plus y minus 3 whole square equals 25 is what is the equation of circle when I do it with the formula. But we need to understand that this can be further simplified to a more simplified answer. Now this equation which is obtained, I would like to further simplify using a minus b whole square for each of these cases. That is, when I have x minus 2 whole square plus y minus 3 whole square equal to 25, then in this case I have this simplified as a square minus 2ab plus b square, and this again is a minus b whole square, so a square minus 2ab plus b square equals 25, which on further simplification gives me, therefore I have x squared plus y square minus 4x minus 6y plus 4 plus 9, which is 13 minus 25 equal to 0. This on final simplification gives me x squared plus y squared minus 4x minus 6y 7 12 equals 0. Is how I get the most simplified equation of a circle with center 2, 3 and radius 5 units. This is how we obtain in the most simplified form. Now let's see the equation of circle in general form. In the more meaningful form of the general understanding of equation of circle is when I take it in its general form. So let's see the general form of equation of circle. So here the circle with the standard equation generally denoted by S, given by x squared plus y squared plus 2gx plus 2fy plus c equal to 0, is called the general equation of circle. And here the center of this circle will be, center is minus g minus f, and radius is root of g squared plus f squared minus c. So these are the two basic formulae I have for the general equation. So for the equation of circle in general form as x squared plus y squared plus 2gx plus 2fy plus c equal to 0, the center of this circle is minus g minus f and the radius is root g squared plus f squared minus c, is how we understand. And it's very important to note that since radius is root of g squared plus f squared minus c, and root is defined only for a positive value, at the most for 0, therefore radius equal to positive square root of g squared plus f squared minus c makes me understand that I derive a very important note, because anything inside the root must be greater than or equal to 0. G squared plus f squared minus c must be greater than or equal to 0 for an equation to define a circle. This is very important. G squared plus f squared minus c must be greater than or equal to 0. So now that we have defined the general form of equation of circle, let's take an example problem to understand the concept more better. Say for example, I have a problem which says find the center and radius of the circle, which is given by the equation 3x squared plus 3y squared minus 6x plus 4y minus 4 equal to 0. So I have a circle whose equation is given by 3x squared plus 3y squared minus 6x plus 4y minus 4 equal to 0. and the question is to find the center and radius of that circle. So let's see how we can do this problem using the general form of equation of circle. So in this case, if I have clearly, when this equation is compared with the standard form x squared plus y squared plus 2gx plus 2fy plus c equal to 0, which is the general form of equation of circle, I clearly see that this coefficients do not match. Therefore, in order to reduce this into the general form, I need to eliminate 3 from x squared and y squared. So therefore, in order to eliminate 3 as the coefficients of x squared and y squared, I divide the whole equation by 3, so that this, when divided by 3, gives me x squared plus y squared minus 2x plus 4 by 3 y minus 4 by 3 equals 0 by 3, which is 0. So this is the equation of circle in general form. Of equation of circle. Now from this I am going to extract the center and radius. Now we all know that the center of the standard form is given by minus g minus f, and the radius is given by root of g squared plus f squared minus c. So in order to find the center and radius as required in the question, I need to find g, f and c from this. So let's see what is g. Now when I compare this with this equation, the coefficient of x, which is 2g, is coefficient of x, which is minus 2. Therefore 2g must be equal to minus 2. So comparing, I get 2g equals minus 2, and my 2f, which is coefficient of y, must be equal to 4 by 3, which is coefficient of y here. So therefore 2f must be equals to 4 by 3, and my constant, which is c here, and the constant, which is minus 4 over 3, must be equal. So I get c equals minus 4 over 3, from which I get g, f and c. So therefore when I simplify, I get g equals minus 1, f equals 2 over 3, cancelling this with this and this with this, and my c is minus 4 over 3. So these are the three values which I'm going to substitute in the formula for center and radius, where I get the center and the radius.